Hi guys, welcome to Mewi Science channel. This is our episode 2. In episode 1, we talked about alkanes and the nomenclature of alkanes using IUPAC, called the International Union of Pure and Applied Chemistry. Today, we'll be looking at common names. How do we name these alkanes using common names? But before we start today's class, please, I would like you to do subscribe. You check down, you see the subscription button there. You subscribe. Hope you've done that. You also like. You can also share with your friends, and then you comment at the end of this class. Okay, today we'll be talking about common names. In our last class we said alkanes have the general formula CnH2n plus 2. This is the general formula for all alkanes. And then we also mentioned some certain alkanes, the first 10 alkanes. And we also talk about the IUPAC nomenclature. But today we'll be talking about the common names. Certain branched alkanes have common names that are still widely used today. So apart from the IUPAC name that we also have the common names that are used for alkanes. It is very, very important for us to know how to name alkanes using common names. Why? Because even in some exams, you will be asked to use common names to name some certain alkanes and other organic compounds. So for instance, if we have something like this, we have CH3, CH2, CH2, and CH3. According to our IUPAC nomenclature, if you want to name this particular compound, the first thing to do is to count the number of carbon. So what you do is you count the number of carbon in the chain. So if you count the number of carbon here, you have 1, 2, 3, 4. This particular structure or this particular compound has 4 carbons. Therefore, according to the common name, you just apply N. You put in your N here. N. This N stands for normal. So this is our normal butane. This is our normal butane. This particular compound is in the straight chain. So apart from the straight chain alkane or straight chain organic compounds, or you call it hydrocarbon, we also have the branched alkanes, and this is where the common names comes in. So in the branched alkane, there are some certain names that are used as common names. We have iso, we have sec, we have tert, and we have our nil. So these names are the names that we use in common names. We use them as common names. So we are going to learn how to use these names, because most often students they feel confused, they get confused. They don't know the difference between iso and sec. They can't also tell the difference between tert and nil. So at the end of today's class, you should be able to differentiate between iso, sec, tert and nil, and how to use them in naming alkane. Let's start from the first one. We have the iso. We have iso. This iso here represents isomer. It represents isomer. In organic chemistry, we have what we call isomerism. In isomerism, we are talking about the same molecular formula but different structural formula. So the iso here refers to isomer. This depicts isomer. So when do we use isomer? Basically, we use isomer for 2-methyl alkane. 2-methyl alkane. So this is basically used for 2-methyl alkanes. That is when we use iso. for 2-methyl what? Alkane. What do I mean by this? When we have our substituent on the second carbon of an alkane chain, we use what? Iso. I'll give an example. Alright, if we have something like this, let's say we have CH3, we have CH, we have what? CH3, and we have what? CH3. Okay, let's name this compound now using what? Our common name, iso. Iso is basically used for 2-methyl what? Alkane. 2-methyl alkane. So if we have this structure here, we have our methyl group on the what? On the second carbon of this alkane what? Chain. So whenever you see something like this, this is what? Iso. Let me use our red marker. Alright. So we have something like this. This is what? Iso. Whenever you see something like this, it is what? Iso. So how do we name this compound using common name? Because we know this is iso, we first of all bring out our iso. After bringing out iso, then you count the number of carbons in this particular structure. We have carbon 1, carbon 2, carbon 3, and carbon 4. 4 carbons. 4 carbons stands for what? Butane. So we have what? Butane. Very simple. This is how we name organic compounds, or this is how we use common name in naming organic compounds using what? Iso. Basically for what? 2-methyl what? Alkane. When we have our methyl group on the second carbon of an alkane chain, it is called what? Iso. If you also look at this, CH3, CH2, okay, CH2 and CH3. Then we have this CH3. Alright. So this is also iso. Therefore, if we are naming this compound, we first of all bring out our iso. After bringing out iso, then we count the number of carbons in this compound. 1, 2, 3, 4, 5. 5 stands for what? Pentane. So this is what? Iso what? Pentane. Very simple. Alright. Then how do we place in sec, tert, and what? Nil? How do we do that? Alright. Before we go into this, we should look at what we call what? Classification of what? Carbons. In nomenclature or in organic compounds or in alkane, carbons are what? Are classified. They are classified into 4. We have the primary carbon, we have the secondary carbon, we have the tertiary carbon, and then we have the what? The quaternary what? Carbon. So if we have this primary carbon, let's say this is primary what? Carbon. You can write it this way, 1 degree. Primary carbon. Primary carbon is a particular carbon bounded with what? Just one what? Carbon. So when you have one carbon attached to just one singular carbon, that carbon is called what? Primary carbon. If you have something like this, then let's use array. And then we have our CH3. Alright. This carbon here is what we call what? Primary what? Carbon. Why is it primary carbon? Because this particular carbon is attached to just one single carbon. The R here is our substituent. That's our substituent. So this particular carbon is attached to just one singular what? Carbon. So we call this what? Primary what? Carbon. We also have secondary carbon. Secondary carbon in the form of this. This is our substituent. Then looking at right, we have this. Alright, we have this. And then we have CH3, CH what? 3. In this case, this particular carbon atom is attached to what? 2 other carbon atoms, this one and this one. So this particular carbon atom is called what? Secondary carbon atom. We also have our tertiary carbon atom. We have something like this. Let's see, we have something like this. We have CH3. Okay. Let's use our red. We have CH. Okay. Let's remove this. We have our CH3 here. We have our CH3 here. And then we have what? CH3 here. Let's say this our substituent. If you look at this very well, this carbon atom is attached to 3 other different carbon atoms. 1, 2, 3. So this is called what? The tertiary what? Carbon. Then the last one, we have the quaternary carbon. So if you have something like this, CH3, we have CH3, we have CH3, we have CH3, and then let's use our red for this. Okay. Alright. This particular carbon atom here is attached to 1, 2, 3, and what? 4. 4 carbons. So we call this what? The quaternary what? Carbon atom. So basically, if we are using the sec, this sec here is used for what? Secondary what? Carbon. Secondary what? Carbon atoms. For example, if we have something like this, let's say we have our CH, we have our CH2 and then our CH3. Alright. This particular carbon atom, which has the substituent attached to it, also has what? Carbon 1 and carbon 2. It has 2 carbon atoms attached to it. Therefore, if we are using this common name, if we are using the common name method, if we are using the common name method to name this, what we do is, this is sec because it is a secondary carbon. We'll do it as sec, and then we'll count the number of what? Carbon. 1, 2, 3, 4. And 4 stands for what? Butane. So because of the substituent here, it will be called butyl. Sec what? Butyl. Sec butyl. Let's say for example, chlorine or chlorine. If we have chlorine, you can call it sec butyl what? Chloride. Sec butyl what? Chloride. Why? Because the chlorine atom is attached to a secondary what? Carbon atom. Okay, if we have something like this, this is the what? The tertiary, right? This is the tertiary. So if we have a substituent, maybe chlorine attached to it, how do you name this now? Because we're having carbon attached to maybe a chlorine. This is chlorine as a substituent. This chlorine is attached to what? A tertiary what? Carbon. Therefore, it will be what? Tert. How many carbons? 1, 2, 3, 4. Butyl. And then what? Chloride. That is how we name it. How about this? The neo. In the neo, let's take for instance, we have something like this. CH3. We have C. We have CH3. We have CH3. we have what? CH2, and we have what? CH3. How do we name this compound? Using what? Using the common name. Because this carbon atom is what? A quaternary carbon what? Atom. And this represents what? Our nu. So to use the common name method to name this particular compound, we first of all bring out our what? Our nu. And then we count the number of what? Carbon atoms. We have 1, 2, 3, 4, 5, and what? 6. So the name will be what? Nu what? Hexane. Very what? Very simple. So sec, the name sec is used for what? Secondary what? Carbon atoms. The name tert is used for what? Tertiary what? Carbon atoms. And then when we have a tertiary group here, the tert group here, attached to 2 other carbon atoms, we use what? The nu. Or you can basically say, when we have this quaternary and then we have another extra carbon atom, then we use our what? Nu. But for the iso, it is when we have 2 methyl what? Alkane, a substituent like this, a methyl substituent like this, attached to the second carbon of what? An alkane group. That is how we name compound using what? Common names. Iso, sec, tert, and what? Nu. Very simple. Alright. So finally, let us use common name to name what? This compound. We already know how to name this compound with what? Our IUPAC name. I'm very sure if you had followed me in our first episode, you should be able to name this compound using the what? The IUPAC method. But let's use the what? The common name method to name these compounds. We have just 3 compounds here. Okay. The first compound, to name this, what we do is to look for the what? The longest what? Tail. That should be the first thing that will prick your mind whenever you want to name an organic compound. You should first of all think about what? The longest tail. So how do we do this? I'm going to use our view tool, our view marker. Let's look for the longest tail. We have carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and what? Carbon 6. That's hexane. Alright. Apart from that, I think there is one other way we can still number these carbons here. Let's use our red marker. Alright. Let's number this way. Carbon 1, carbon 2, we have carbon 3, we have our carbon number 4, carbon number 5, carbon number 6, and carbon number what? 7. Wow. Okay, if we number this way, we get 6 carbon. While if we number this way, we get what? 7 what? Carbons. Okay, therefore we are going to use this other way because it is giving us the longest what? Chain. Let's erase this out. Let's erase this out. So the longest chain is what? Our heptane. The longest chain is heptane. We should know that the longest chain is what? Heptane, 7 carbon. The next thing we have to consider is what? The substituent. We have substituent here, and also have what? Substituent what? Here. This substituent is the methyl substituent. The methyl substituent on carbon 2. Why this particular substituent is what we call the iso what? Propyl. That is the common name. Isopropyl. You might wonder, how is it isopropyl? Okay, let's do it together using our view marker. We have something like this. What should this bring to your mind? Iso, like we said it here. Iso. So it's the same thing. This was the iso. The next thing will be counting the number of carbons. 1, 2, what? 3. It has what? 3 carbons. And 3 carbons stand for what? Propane. But because it is a substituent, we call it what? Propyl. So this is iso what? Isopropyl. What then would be the name of this compound? The isopropyl is on what? Carbon what? 4. So write 4 isopropyl. The next substituent is the methyl group. The methyl is on carbon what? 2. 2 methyl. And then what's the longest chain? The longest chain is what? Heptane. Heptane. Wow. So that is how we name compound using common what? Name. 4 isopropyl, 2 methyl what? Heptane. This is what? Iso group. From what we said, this is what? Iso group. Alright, let's name the second compound. Very simple. This is already the longest chain. From this, we know this is what? The longest chain. Let's use our red marker to identify. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And 10 stands for what? Decane. Decane. Okay, let's move to the substituent. The substituent here. Using our blue marker. The substituent now. We have this particular substituent on carbon what? 5. We don't want to use the IUPAC method. We want to use the common name. So we have something like this. I see this. I see this. I see this. What should this bring to your mind? This is what the iso. Is what iso, because we have this methyl group on the second carbon of this what chain. Since we recognize that this is iso, then we'll count the total number of carbon in this compound. 1, 2, 3, and what? 4. 4 stands for what? Butane. So this is what? Iso what? Butyl. What then would be the name of this compound? The isobutyl is on carbon what? 5 of this decane. So the name would be what? 5 isobutyl decane. Simple. Very simple. Alright. Whoosh. Some will be like, this is complicated. This structure is complex. It's not complex. Let's identify our longest chain. Identify the what? The longest chain. Alright. We can number this way. Let's start our numbering using our red marker. I always like using red marker to number. I don't know why. Red. Oh, let's use red for this. 2. You can number this way. 1, 2, 3, 4. This is what? Okay, sorry. 4, 5, 6, right? 1, 2, 3, 4, 5, 6. Push. We can also number this structure in another way. We are actually looking for the longest chain. The longest chain now. Okay. Let's number it in another direction using our blue marker. 1, 2, 3, 4, 5, 6, 7. Wow. I think this is the longest chain. So we use this 7. We use 7, which is 13. Then let's erase this. Erase this. Erase this. Erase this. And erase this. Alright. So this is the longest chain. 13. 13. The next thing we'll look at will be the substituent. We have, okay, let's use our black now. Let's use black. Let's use red. We have one substituent here. We have another substituent here. And then we have another word, substituent. Here. You, am I correct? Of course. We have substituent, and we have what? Substituent. Let's focus on this last substituent. We have carbon here. This carbon is surrounded by three other carbon molecules, three other carbon atoms, sorry. This particular carbon is surrounded by this, and what? This. So what should that do to our mind? Tertiary what? Carbon. So we use what? Tert. And then we'll count the number of carbon atoms. 1, 2, 3, 4. Right? 1, 2, 3, and what? 4. So it will what? Tert what? Butyl. Tert butyl. So what then will be the name of this what? Compound? The tert butyl is on carbon what? 4. Let's use blue. Naming it, since we'll be using blue, let's use a blue. We have the tert butyl on carbon 4 of heptane. So the name of this compound will be what? 4 tert butyl. Okay, and then we have a substituent, the methyl group on carbon 2, another methyl group on carbon what? 3. 2, 3 what? Dimethyl. These are methyl. It's methyl. Yeah. 2, 3 dimethyl. The longest chain is what? Heptane. Heptane. The name of this compound would be 4 tert butyl 2, 3 dimethyl what? Heptane. Why? Because we have our tert butyl. This is the tert butyl on carbon what? 4. Why is it tert butyl? Because we have this carbon atom surrounded by 3 other carbon atoms. This is the tertiary what? Carbon. Tert what? Butyl. 4 tert butyl. This tert butyl is on carbon what? 4. Then these 2 stands for this other methyl group. The 3 stands for this other methyl group. And then because we have 2 methyl groups, it is called what? Di. The longest chain is what? Heptane. Therefore, our name is 4 tert butyl 2, 3 dimethyl what? Heptane. This is how we name what? Organic compounds, or basically our alkane, using what? Using common names. Therefore, don't forget that whenever we see a methyl group on the second carbon of a chain like this, we use what? Iso. Whenever we see the substituent attached to a secondary carbon, we use what? Sec. Whenever we see the substituent attached to a tertiary carbon, we use what? Tert. And then whenever we have something in form of a quaternary carbon having extra carbon here, or it has an extra carbon, we use what? Nil. That is how we name what? Organic compounds, using what? Common names. Some students, they can name organic compound using IUPAC name, but they don't know how to use common name in the nomenclature of what? Organic compounds or alkane. But it is very necessary as an organic chemistry student for you to be able to use both IUPAC name and what? Common names. Is very good. That shows that you know what you are doing. Thank you. This is our second word episode. In our third episode, we'll be looking at what? Cycloalkanes. Please, I would love you to keep on following Me with Science episode by episode. If only you can do this, I promise you that organic chemistry will be simplified to you, and you'll do very well in your what? Field of study. Because once you are doing very well in organic chemistry, it means you can also do well in other what? Field that you are into. Please do well to subscribe if you've not done that, share, then you also like. You can now comment your questions and your contributions. Thank you.
There are times